Hey guys, my name is Trevor Sullivan. I'm a solutions architect on the Stratus Grid team, and welcome back to our video channel. In this video, I wanted to talk about a management and governance service called AWS Config that allows you to build custom compliance rules to help validate the resource configurations of your AWS cloud resources, as well as any custom resource types that you want to incorporate into the platform. So if you'd like to visit us online, head out to stratusgrid.com. This is our website here. You can hit this button up here called Let's Talk. And if you want to reach out to our sales team to talk about a project that you're interested in doing around AWS, we'd be more than happy to talk to you. Also, we have our own SaaS tool called Stratosphere. And Stratosphere is basically a cost optimization tool that helps your entire organization to find cost savings opportunities in AWS and really extract more business value out of your use of AWS. Also, you can find us on our partner page over at the AWS Partner Central here. If you just do a search for Stratus Grid, you can find our partner page here. And this talks a little bit about our background and our partnership with AWS. We are a premier consulting partner with AWS, as well as an ISV that provides Stratosphere as a FinOps solution. All right, so our topic for today is going to be around the AWS Config service. And before we jump into the specific process of building custom rules by using the CloudFormation Guard rule syntax, I wanted to give you just a little bit of background on the config service itself. Now, AWS Config has actually been around since 2014, so it's about 10 years old at this point in time. And originally, when AWS Config came out, it only gave you the ability to inventory a few essential resources in your account. So one of the most fundamental capabilities that the config service provides is resource inventory here. And what this allows you to do is to basically just search across all of your different resources in your AWS account. So things like EC2 instances or Lambda functions or things of that nature. This is kind of a one-stop shop for you to find resources across your entire AWS account. So resource inventory was one of the original capabilities that the config service provided. It wasn't until a little bit later, I believe later in 2015, that they provided the ability to add rules or compliance rules into your AWS account. And these compliance rules allow you to validate the configurations of the resources that are being discovered or inventoried by the AWS config service. So these inventory and compliance rule capabilities really go hand in hand with each other so that the compliance rules can evaluate each of the resources in your AWS account and determine if they are compliant or not compliant with the rules that you've applied to your AWS account. Now, when it comes to the rules capability here, I wanted to point out that there's some different types of rules. You're going to see in this list of rules that I currently have configured in my account that under the type heading here, we have some rules that are AWS managed, and we have some that are called custom policy rules here. So you can actually create your own user-defined or customer-defined policies inside of your AWS account built on top of the AWS config service. And there's actually two different ways as of this recording that you can build these custom rules. The one way that you can build your own custom rules, if we click on Add Rule here, is to use custom Lambda rules. So you can actually write a Lambda function that performs some logic to determine if a resource is compliant or not compliant, and then that can return the result back to the config service. Now, this is a little bit more of an involved process because you actually have to write the Lambda code yourself. You have to deploy the Lambda function into your AWS account, and then you're now responsible for maintaining that function, for resolving any bugs in that function, for updating the dependencies for that function as well. So you kind of own that custom code. But there's actually a newer way that was just released within the last couple of years called the Guard rules here. And Guard is actually a utility that came out of the CloudFormation team originally, because what it allowed you to do is take a CloudFormation template after it's been rendered with all the final values, and then you can actually evaluate the settings for all those different resources against a set of rules called Guard rules here. And basically that would allow you to kind of gate a deployment of a CloudFormation template based on whether those settings or configurations for each of those resource properties complies with your organizational policies. However, more recently, AWS has actually added the ability to allow you to use guard rules directly inside of AWS Config. And I believe this was released somewhere in the 2022 timeframe, if I recall correctly. There is an AWS announcement about that. I think it's actually right here in August of 2022. You can actually build AWS config rules using CloudFormation Guard. So this is not even 2 years old yet as of this recording. So what we're going to be doing is talking about how to create a custom rule using Guard. And when you go to use this capability for the first time, you might just come into the AWS config service. You might go over to rules here, say add rule, and then click next and go ahead and fill out all the details for the custom Guard rule here. But I'm actually going to show you an easier way to build these Guard rules that is going to reduce the amount of friction and improve the ability for you to iterate on these rules as you're building them out. And then once you've built out the rules locally and you've determined that they work according to your specific needs, then you can go ahead and copy and paste those rules into the AWS config rule here so that you can create them and start evaluating against live resources in your AWS account. So that's really the topic here, is figuring out how to use this guard syntax in order to build custom compliance rules in your AWS account here. Now, remember that in the resource inventory screen right here, we can inspect any of our AWS resources that are currently supported by AWS Config. Keep in mind that not every resource type is necessarily supported by AWS Config. Over the past 10 years or so, AWS has been adding support for more and more types of resources. So you will see a pretty hefty list in here at this point in time. But remember that the specific type of resource that you're trying to evaluate might not yet be available in the config service. But if we search for common things like EC2 subnets, for example, or something like EC2 dedicated host, I think that's also supported. Or at least EC2 instances are supported in here. So let's just do a search for instance. Sure enough, there it is. Search for dedicated hosts, see if that's supported. It looks like that's not either, but over time, they are adding support for more and more types of resources. Now, as you can see, I've filtered my resource inventory here for just EC2 instances and VPC subnets. And if I scroll down, I can see the list of those resources right here in this table. Now, if I drill into one of those specific resources, like this EC2 instance right here, I can see some basic details about that resource. So I can see the resource ID. I can see things like the ARN that contains the account ID, that contains the AWS region where that resource exists. It contains the resource type, which in this case is an instance, and it also includes the specific instance ID. It also tells me what availability zone that resource is deployed into and things like that. But if I scroll down a little bit here, I'm going to see this view configuration item JSON section right here. And this is actually going to show you the entire representation of this resource as it is stored in AWS Config. So as you can see, there are lots and lots of different properties that describe the current state of this resource inside of my AWS account. And I can get this information from AWS Config without having to write a script that goes out and actually queries the EC2 service. I can just have all this inventory information readily available in kind of a miniature managed database inside of the AWS Config service. So now what I can do is actually write a compliance rule by using this guard syntax that originally came out of the CloudFormation team to look at all of these different properties and determine if my resource configuration is compliant with my desired set of rules or not. So in the case of EC2, a really common example of something that you might want to evaluate is the instance type. So is the instance type in one of the instance types that I specifically want my organization to be using? Now, this is useful for a variety of different reasons. First of all, we have cost optimization. So AWS has some very expensive instances, like the X1E series of instances that can be very pricey. Some of the X2i series of instances can also be very expensive, although they did introduce kind of a lower end medium tier for the X2 as well. But depending on what your organization wants to use for EC2 instance types, you can determine either these instance types are compliant with my organization's policies or they're not, right? So we can use these rules to look at the instance type property down here, which is part of the configuration section, and basically determine if this instance type, in this case a C6A large, is a supported instance type for my specific organization or not. So what we're going to do is actually build a simple guard rule that targets that instance type property so that we can determine if this resource is compliant or not. But what's really useful about this view right here is that we can just click on this copy button to copy this to our clipboard, and then we can actually ingest this entire JSON object that represents this EC2 instance into a local project so that we can run these guard rules against a local representation of this EC2 instance rather than actually having to import the rule into the AWS Config service first. And this really improves the iteration times as we're developing these rules. So one of the first things that we're going to need to do is actually take a look at the guard CLI tool itself. So CloudFormation, back when they developed the guard capability, they introduced a guard CLI tool. And if we head over to the documentation for AWS right here, I'm going to show you how to find the documentation for guard. So if you're on the main docs page, docs.aws.amazon.com, you can just scroll down right here and then do a search for CloudFormation. And then when you drill into the CloudFormation service, there'll be a document right over here called CloudFormation Guard User Guide. And this is the documentation that we want to learn how to use Guard specifically. So now we're going to go over to setting up Guard right here. And something that's interesting about Guard is it's an open source project, so you can actually find it on GitHub as well. And it's also developed in Rust. So you can just install the Rust toolchain and then install this utility by using the Cargo CLI, which is one of the tools that's installed with the Rust toolchain. So you don't have to necessarily be a Rust developer, but you just need to install the Rust tools so that you can install this tool directly from the crates.io registry. So one of the first things you're going to want to do is to install Rust. So let's do a search for install Rust here. And if you head out to the website for Rust here at rust-lang.org, you can see that there is this command here that you can run in order to install the Rust tool chain on your system. So this is going to give you the Rust up utility. And then once you have Rust up on your system, you can just do a Rust tool chain installation, and you should get eventually the Rust CLI installed here. The Rust C, I should say, it's the Rust compiler. Also, you can see I've got Cargo installed here. So Rust up is the kind of tool that you use to manage your installations of various toolchain versions. So Rust up here, I can do Rust up toolchain list, and I can see that I currently have the stable toolchain involved. I can also do a Rust up check to check for newer versions of the toolchain, but as of this recording, I'm currently using the latest version of the toolchain, which is 1.77. So once you've got the Rust toolchain installed on your system, whether it's Windows or Mac OS or Linux, doesn't matter. The Rust toolchain is kind of universal to all those operating systems. The next thing that we're going to do is to install the utility, the Guard utility specifically. So what we're going to do is do cargo install cfn guard, and that'll install this onto our system. So it's going to go out to crates.io, which is basically the registry where a bunch of Rust packages exist. It'll download all the dependencies for the Guard utility, and then it'll go ahead and compile those and make the Guard CLI available on our local system. And then we can invoke that by calling cfn-guard, which is the actual name of the binary itself. So then once we've got that utility installed, we should be able to run it, just called cfn guard right here. And then what we want to do is actually create a simple code project where we can actually instantiate some rules to test out, right? So what we're going to do is create a new project directory. So let me open up a new shell right over here. I'll go into my parent Git directory here, and then I'll just create a folder here called stratusgrid-config-guard. And then I'm just going to go ahead and open up Microsoft Visual Studio Code. So you also want to install VS Code. If you don't have that, you can get it at code.visualstudio.com. This is an excellent cross-platform editor that works really well for any kind of code projects, whether it's Python or Rust or building AWS Config, guard rules. It's really up to you, but it's just a great text editor. So let's open up this folder, Stratus Grid Config -guard right here. And then we're going to create a guard rule inside of this folder here, and then we'll be able to test out that rule locally before we actually import that rule into AWS Config. So let's go ahead and check on the installation of CFN Guard. So it looks like it is installed right here. We've got the latest version, 3.0.3. And I also did want to point you to the project page on GitHub. So if we do a search for GitHub and look for Guard, CloudFormation, that should show us the repository here. Just go to the home page. And so this is the GitHub repository for CloudFormation Guard. There is additional documentation in here as well as far as building out rules for the service here, but there is also the AWS documentation that you can refer to right over here. So if we go to the AWS docs and then take a look at getting started with Guard, it'll show us some examples of how to actually write Guard rules. But essentially, a lot of these examples that you're going to see in the documentation do not apply to the AWS Config service. So what you're going to see is references to things like resource properties in here. So if you were evaluating a CloudFormation template like this YAML template right here, we have the top level resources property that defines the different resources. Then we have the CloudFormation logical resource identifier right here. And then we have all these different properties that represent the actual resource itself. And so when you see some of these examples in CloudFormation Guard, you're going to see references to this top level resources property, because that's generally how you would evaluate resources with the CloudFormation service if you're evaluating CloudFormation template. But in this case, we're actually evaluating AWS Config resources rather than evaluating CloudFormation templates. So we're not going to start by evaluating this top level resources property. We're actually going to start by inspecting the configuration of our resource as it appears in the AWS Config service, which we looked at right over here, right? So if we want to inspect a certain property, we would just drill into this JSON object that we have right here, and then start taking a look at the path in JSON where we want to inspect. So we drill into configuration, drill down into instance type, and that will return the instance type that we have right here. And then we can write a guard rule that actually evaluates against that instance type. So long story short, we're going to write a rule that looks at configuration.instanceType and see if the value falls into a set of values that we want to allow our organization to use. So what we're going to do is head back over here to our project in VS Code, and we're just going to create a new rule. I'm just going to call it ec2-instance-type-check.rule. And then inside of this rule file, we can go ahead and define the syntax for a specific rule that we want to create. Now, if we head back over to the documentation here and drill down under composing named rule blocks, this actually talks a little bit about how a typical rule file is going to look. So you can actually have a rule that has multiple embedded rules or multiple checks inside of that named rule. So typically, your file is going to start out with a rule keyword that indicates that we're creating a new rule. Then you'll give that rule a name, and then you can specify each of the individual checks that you want to perform against a particular resource. So what we're going to do is say rule ec2 instance type check. And then inside of these curly braces right here, we're going to specify the property that we want to inspect. And then we're going to use an operator like the equality operator to determine if the value of that property equals a certain value or not. So in this case, I'm going to drill into the configuration block of our sample resource that we have right over here. And then we're going to use a period and say instance type. And we're going to check to see if this instance type is equal to c6a.large. So we're expecting at the moment, because this instance that we have right over here as an example has the instance type of c6a large, we're expecting that this rule is going to pass or validate. So you can have pass, You can have failure. So if it fails to pass an evaluation and it doesn't meet the criteria, that's considered a failure. But then some types of rules are not going to apply. Like, it wouldn't make sense for me to have a rule that checks the instance type that runs against a Lambda function, because a Lambda function doesn't have an EC2 instance type associated with it. Same thing, it goes for other types of resources, like an S3 bucket. It wouldn't make sense to check the instance type of an S3 bucket because S3 buckets just don't have an instance type, right? So what we can do to actually filter out the instance types, or I should say filter out the resource types that we want a particular rule to check, is to actually look at the resource type field right up here. So one of the things that you might notice in the documentation for these rules over here is that there is a when clause right here. So we can use a when clause to filter out resource types that are not applicable to a particular rule. So over here, I could say I want this rule to run. So I want rule EC2 instance type check to run when the resource type is equal to AWS EC2 instance. And so that way, if for some reason we attempt to evaluate this rule against an S3 bucket, the first thing that's going to happen here is the S3 bucket resource type is going to get filtered out, because the resource type of an S3 bucket is AWS S3 bucket rather than AWS EC2 instance. And so that is an indication to the guard utility that this rule would not apply to an S3 bucket or not apply to a Lambda function and things like that. So this is how we can make sure that we filter the resource types that we want our rule to apply specifically to. So now this rule check that we've embedded right here inside of this parent rule is only going to run on EC2 instances. So now if we want other types of rules to run against EC2 instances, we can simply add those as additional rule checks inside of our rule block that already has the filter applied to it. But for now, let's just go ahead and stick with this one rule that we have right here. And then we're going to take a look at how to run the CFN guard utility against this rule. And then we're actually going to pass in some sample data. So for starters, let's open up our terminal down here and run cfn-guard and take a look at the syntax for this utility. So what we want to do is use this test command right here to test our rule against the rule that we have defined right up here. Actually, we might want validate right here. So we have unit testing for the guard rules file, and then we have validation. So for now, I'm just going to stick with test. So let's do cfn guard test. And then you can see down here, we have rules file. And so that'll allow us to specify one or more rules files that we want to pass in. And then we can specify our test data, which can be either JSON or YAML syntax. So let's go ahead and build out a very simple script right here. So I'll just call this run.ps1, and we're going to call cfn guard test rules file, and then we're going to specify EC2 instance type check.rule. And then we also want to specify a test data file. So we need to construct this test data file so that we can pass in some sample data into this rule file here so we can evaluate whether these rules are working properly or not. So what we're going to do is actually create a test data file. So let's do test data.json here. And let's plug that path in right here into our CLI command. All right, so here's what our CLI command looks like for CFN guard. Let's go ahead and try to run it and see what happens. Well, as you can see, we don't get anything here, and that's because we haven't populated our test data JSON file. So the test data JSON file needs to be a JSON array at the top, and then we can embed specific configurations for our evaluation rules that we want to apply to determine if they are going to run or not. So what we need to do is to go ahead and add a couple of properties to each of these test rules here. So if we try to run with an empty rule set here, you're going to see that we get an error. It says it's missing field input. So we have to specify an input field here, and then we can simply paste the entire resource configuration that we copied from the AWS Config service. So again, you can just go over to AWS Config, go to the specific resource that you want to check against, go to View Configuration Item, and then copy the entire JSON definition to your clipboard, and then you will just basically paste that right after the input field on this JSON object inside of an array in your test data input. So let's go ahead and try to run again, and you're going to see that it's now missing a field called expectations. So inside of this JSON object right here, we're going to do expectations, and then this, I believe, is going to be an array. Actually, no, this is going to be a JSON object, and then what we're going to do is actually specify the rule name followed by the result that we expect. So in this case, we're going to say that we expect this rule right here to pass against this specific input, right? So let's go ahead and try this again. And it says missing field rules. So I think we actually need to put a rules child property in here as well. And then let's go ahead and bring this up here. And so we're going to put this right up here. And I think that's the correct structure. Okay, so now you can see that our rule, EC2 instance type check, is expected to pass, and it did indeed pass. But we could actually make that fail very easily by simply changing the instance type right here in the rule. So let's say we expect it to be a C7G.large. And so now you can see that there's a list of failed rules. This rule is the one that failed. We expected it to pass, but the actual evaluation was a failure. Now you can also set things to skip as well. So if this resource that was being provided as input was some other type of resource, like an S3 bucket or a Lambda function or anything where we would expect this rule to not apply to, we could actually specify skip right here, and that would allow us to check to make sure that the resource was actually skipped. And so in this case, you can see that it's going to fail once again because we expected it to skip, but it didn't actually skip because this rule does apply to EC2 instances. So in this case, it wouldn't make sense for us to put skip here. It generally was going to make sense for us to have a pass result right here. But if we added another resource, so let's find something like a Lambda function. So we'll go search for Lambda functions here in our resource inventory. And I'm just going to grab one of these right here and find the JSON for that Lambda function. And then under configuration here, you can see all the Lambda properties, like what's the code size, what's the runtime, what's the function's name, things of that nature, what's the memory size. And so what we can do is copy that and bring this in as a second test case, right? So I want to test rules against EC2 instances, but I might also want to run those rules against Lambda functions just to make sure that they're behaving appropriately. So in this array of test cases, we're going to add another test case right here. And this time we're going to set the input as the Lambda function that we just copied from AWS Config. And then we're going to set the expectations to be a JSON object. And we're going to have rules here. And then in our list of rules, we're going to expect that this rule right here should be skipped instead of passing, okay? So we'll do skip right here. Let's go ahead and contract that. And down here for the EC2 instance input, we expect it to pass. So now we can go ahead and run our CFN guard script right here again. It's going to just pass in our rules file right here, pass in our test data. And so now you can see that test case number 1 is we expected it to skip, and it did indeed skip. And then under the second test case here, which is the actual EC2 instance, you can see that we expected it to pass, but it failed. And that's failing because we have a mismatched EC2 instance type right here. So we know that in this case, in order to fix this, we either have to update our rule to include the type of EC2 instance that we have over here in the actual instance configuration, which is C6A large, or we need to actually modify the configuration of our resource in our AWS account. And so this is helping us to identify any resources that are non-compliant with the rules that we are declaring for our AWS environment, right? Now, in this case, we are using the equality operator right here. But in some cases, you're going to need to do comparisons against something else, like an array, for example, or maybe you want to do an evaluation against an instance family. So another way that we could actually do this here is to say, well, I want anything with the 7th generation to be allowed. And so what I could do, instead of saying equals a specific string value, is I could actually do a match operation against a regular expression. And to do that, we can specify a regex by using the forward slashes here. And then I can just look for a 7 anywhere in the instance type. It doesn't have to start with a 7. It doesn't have to end with a 7. The 7 could appear anywhere inside of the instance type string, and this should ultimately match. So let's go ahead and rerun our check here. And it looks like that failed. And of course, it's failing because it's C6A. So even though C7A I don't think is a valid instance type yet, I'm going to change it to that anyway and rerun our rule. And now you can see it is indeed passing. So we can do regex matches here. We could also do something like 6 or 7. So regex is kind of its own topic. We're not going to talk about in too much depth here, but you can use this or operator where it has to match a 6 or a 7. So I could say it has to be a C6 or it has to be a C7, and then C7A should match. So let's go ahead and run that. Sure enough, that does pass. And then if I change it to something like C6A large, which I believe is the original value that it actually was, then that also is going to pass, because in our regular expression, we're saying it could start with C6 or it could start with C7. Or more correctly, we could say start with C6 or start with C7 by using the caret, which indicates the beginning of a string. And if we run that, you can see, sure enough, that passes as well. Now, if we try to do something like say, oh, it should end with C6 or end with C7, then those are going to fail because the C6A or C7A or whatever values those are going to appear at the beginning of the string. So as you can see, regex is working properly here. We just have to make sure that we specify the correct regex to match those. Now, this is going to match anything. So this could match a C6 2x large. It could match a C6A 4x large. And in some cases, we might want to match to specific values. So I want to allow C6A large or C6A 2x large, but I don't want to allow C6A 4x large or 8x large or things of that nature. So something else that we can actually do is use a different operator. And all these operators are documented over under writing guard rules here. And again, this documentation does focus on evaluating CloudFormation, not necessarily AWS Config inventoried resources, but the operators still are going to apply regardless. So let's search for operator down here. And under operators, we have equality operator. We have the not equal operator. We have greater than. So for things like numeric values, like in the case of our AWS Lambda function, we had a code size that determines the size of our code package. We could write a rule that says, is my code package greater than 5 megabytes, right? And we could fail based on that if we wanted to. We can do greater than or equal, less than or equal to. But this is the one that I'm interested in here, is the in. So I want to say, is the instance type that we're evaluating inside of a list of supported values that we explicitly are allowing. Now, you could do that with regex if you wanted to, but this is a guard-specific operator that's supported. So we're going to show how to do that. So rather than using the equality operator, we're going to say in, and then we're going to use the square brackets here to indicate the values that we want to allow. So C6A large will be the only value that we add in here. And now you can see that that rule passes just fine. Or I could say I wanted to allow C6A large and C6A.2x large. So that's still going to pass. But if I change this to C6A.4x large, now you're going to see that it actually fails, right? Because we're saying I only want these two instance types to be allowed inside of my organization. Now, earlier we talked about the benefits of this, one benefit being cost optimization, so we can make sure that things like X1E instances are not being used without some kind of special exception. But we could also make sure that we are periodically phasing out older generation instances, right? So in some cases, I might be moving from the C6As to C7Gs, right? So I can basically build out a custom rule here that says, all right, well, previously my supported values were C6A large, but now I'm actually moving over to ARM and I'm moving over to a newer generation. So now we just change these to C7Gs, and now I can actually go in once this rule has been evaluated in my account to see all of the instances that are non-compliant with this rule, and that right there gives me a list of the instances that we need to go remediate as a team and update those or kind of migrate them over to the ARM-based platform. Now, let's go ahead and write a rule that validates against Lambda functions. So let me really quickly fix this here. We'll do C6A large here. And let's see, did I change that over here? Looks like I did. So I'll go ahead and fix that to C6A large. Now, let's go ahead and write another rule that evaluates against our Lambda function as input here, right? So again, with AWS Config, it's not just about EC2 instances, it's about any resource type that's supported here. So if we go to our supported list of resource types right here, of course, we went to Lambda function earlier, then we navigated to a specific Lambda function. We were able to grab that entire JSON item here that's been inventoried and then paste that in as input here. Now, for a Lambda function, we're expecting this rule to be skipped, right? Because this rule just does not apply to Lambda functions. But what we're going to do is write another rule in the same rules file that does run against Lambda functions. And we're going to put a similar filter clause here to filter out any other types of resources that do not apply. So let's go ahead and write a rule that says Lambda runtime check when resource type is equal to AWS Lambda and then function. And then any rules or clauses that we plug into this rule right down here are going to evaluate exclusively against Lambda functions. So now over here in our test data.json, let's copy that rule name. We're going to go ahead and add a new rule here to evaluate. And we're going to expect this to pass for our Lambda input that we have right down here. But if we go down to our EC2 instance, let's see, let's go ahead and minimize that. Let's expand our EC2 instance. So for the EC2 instance, we're going to expect that this Lambda runtime check should actually be skipped, because again, it doesn't make sense to run a Lambda rule against an EC2 instance resource, right? All right, so let's go ahead and save that. And if we just run this right now, let's see, it says we have a syntax issue right here. And of course, this is happening because we didn't yet add any criteria into our rule here. So let's go ahead and add some code into our rule. Let's go look at our Lambda function and take a look at the input right down here. And so for the Lambda function, if we drill under configuration here and take a look at the runtime right here, we can see that right now we have Node.js 16.x. But if we were to head out to the Lambda service over here, we're probably going to see that a bunch of newer versions of the Node.js runtime are supported. And we could basically create a rule that says, I want to identify any older versions of Node.js that are configured on my Lambda functions. I want to flag those as non-compliant so that I can bring those up to a newer version of the Node.js runtime and make sure that they are using it. So that would be a great use case for this with Lambda. So sure enough, under runtime right here, you can see we've got Node.js 20.x is the latest version available. There is also Node.js 18 and 16, and there's potentially even historical versions that have since been retired. But what we could do is write a rule that basically just checks to see if the runtime is using Node.js 20.x or not. So what we're going to do is go under our Lambda rule and say configuration.runtime in, and then we'll just say Node.js 20.x. And in the future, if there were other versions that we wanted to add, like maybe there's another release that comes out that we want to include in here, we could say Node.js 22.x and so on. So we're just going to check to see if the runtime is in that list or not. Let's go ahead and run that. And as you can see on test case number 1, that's our Lambda function, we have a failed evaluation. And that's because our Lambda function is using the Node.js 16.x runtime instead of either 20 or 22, which could be a future version, right? So this is going to flag our resource as non-compliant based upon this rule here. And for test case number 2, this is our EC2 instance sample input. We should see that the Lambda runtime check was expected to be skipped because that rule simply doesn't make sense to apply to an EC2 instance. So now for our Lambda functions, maybe we want to add in another check based on the code size or the package code size. So again, under the configuration section right here, we have the code size property that has the size in bytes of our package that was uploaded to Lambda. So we could say configuration.code size is less than, how about let's say 5,000. And if we run that, that's not going to, or that is going to pass because we have a code size of 238 bytes. So that's a very, very tiny function, but it's still going to be failing because our runtime is not included here. So let's say that we remediated our function. We're going to fix it and make it Node.js 20, rerun here. Now you can see that everything is passing here because our code size of 238 bytes is less than the 5,000 that we have in our rule right here. And we remediated in our test data here, our Lambda function by updating it to a supported version of the Node.js runtime. But in this rule, we're actually doing 2 different checks against the same configuration item inside of our AWS Config database, right? So now that we've written a couple of rules, how do we actually get these into AWS Config? Well, this is where we go ahead and just copy the actual rule itself and then simply add it into the AWS Config service. So in this case, we'd have to create 2 different rules. Let's head back over to the config console right here and go down to rules, go to add rule right here. And this is where we're going to choose the option to create a custom rule using guard syntax. We'll hit next here. And then let's call this Trevor-SG-EC2-instance type. Also, I think that the first character here cannot be a capital letter. So if you run into an error saying that there was some parameter validation issue, then you probably want to make sure that that is a lowercase letter. That can be kind of a frustrating issue to run into. And then we're going to paste this rule text in down under the rule content here. Now, when we scroll down a little bit further, we have the evaluation mode right here. You can't use proactive evaluation for whatever reason. Even though we have a guard rule here, when I try to turn on proactive evaluation, that always seems to cause a problem with creating the rule. So go ahead and leave that off. But then under the scope here, this is where we want to choose specific resources that this rule is going to evaluate against. And remember that AWS Config is actually paid based on the number of rule evaluations. So we don't want this rule being evaluated against a bunch of resource types that are not applicable to it. So this is your opportunity to specify which resource types in your AWS account you want this rule to actually be validated against. So for the resource type right here, we'll just search for EC2 and find EC2 instance and go ahead and select that. And then we'll go ahead and scroll down, just say next and save. And then I'm going to create another rule for the Lambda functions. So we'll say create another rule. We'll say Trevor SG Lambda runtime. And for the rule content here, we'll go ahead and copy our Lambda code, paste that in right down here, and say resources and limit it to run on the Lambda function resource type. Go ahead and hit next and save. And now in our list of rules, we should now see that we have a couple more custom policy rules. We have Trevor SG Lambda runtime and Trevor SG EC2 instance type. And if we drill into Trevor EC2 instance type right here, we can actually see that all 3 instances that are currently being evaluated against this rule are non-compliant, and that's probably just because those EC2 instances do not fall into the list that we have right here. So if we go over to our EC2 console here, and actually if we change this to compliant, we should see that we have one that's compliant. That's the one that we imported as our test case. But over in the EC2 console, you can see I actually have 4 instances. They're not running right now. They're all currently in the stopped state. But I do have one that's C6A large. So that one is currently showing as compliant right here. But then I have 3 that are showing non-compliant. And you can see that those other 3 that we have that are non-compliant are T4G.nano. So that's why those ones are showing as non-compliant. So I could either update the instance type for these EC2 instances to bring them into compliance, or I could go update my rule with some updated logic and say, well, actually, I do want to include the T4G Nano because I just want to use that as an instance type. So I could go edit my rule, go down here to the rule and say T4G.nano, and include that as a supported instance type. And then after a few moments, once everything gets reevaluated, these non-compliant resources should be brought into compliance. All right, so let's check out the Lambda rule that we created as well. So let's go back to rules, take a look at Trevor SG Lambda. And as you can see, I've got 2 Lambda functions. Let's go over to the Lambda service here. I think one was using the Go runtime and one is using Node.js 16.x. And you can see that both of those are non-compliant. And they're both non-compliant, number one, because one is using Go, not Node.js, but number 2, because the one that is using Node.js is using an older version of the runtime. So if we go over here to this function and then change the configuration of this function, so we'll say edit on this. We want to edit this to use a newer runtime version. So let me just find that option here. Okay, so this is actually over on the code tab right here. So under the runtime settings, we can hit edit and then choose Node.js.20, 20.x, and save that. And now I've brought this Lambda function into compliance with the rule that I've created in the AWS Config service. So it's really up to you to kind of be creative and figure out what kind of rules you want to create and what kind of policies you want to apply for each of the resources inside of your AWS account. These are just a couple of contrived examples that show how to keep our Node.js runtimes up to date, as well as keeping our code size packages relatively small, under 5,000 bytes, but you could customize those rules to be whatever you want them to be. Same thing for the EC2 instance type as well. If you want to add in other types of EC2 instances into that rule, you can do that. If you want to check other things like what subnet the EC2 instances are deployed into, or really any of the different properties that are on these entire AWS config objects here, any of these properties can be evaluated against a guard rule. So feel free to be creative and figure out what your organization wants to do as far as policy management goes. But in any case, I hope that this video has given you some insight into how to build some custom rules locally so that you can iterate on these very quickly before you actually import these guard rules into the AWS Config service and start evaluating live resources. Thanks again for watching, and we'll see you in the next video. Take care.